Hello everybody, I'm Suman Matthews, and in today's video we will be discussing how to integrate partial fractions. This is a part of grade 12 maths, and for more videos you can visit my website www.mathmedec.co. The method of partial fractions can be used only when the degree of the numerator is strictly lesser than the degree of the denominator. So if we come to the first problem, evaluate integral x by x plus 1 into x plus 2 dx. Here degree of the numerator is 1 and degree of the denominator is 2. And the denominator is clearly factorized into x plus 1 into x plus 2. So we write x by x plus 1 into x plus 2 as a by x plus 1 plus b by x plus 2. Take the LCM. So x equal to a into x plus 2 plus b into x plus 1. To find a, you take the denominator of a, which is x plus 1, equate it to 0. So to find a, put x equal to minus 1. So I get minus 1 equal to a into 1. So a is minus 1. To find b, put x plus 2 is 0. So x is minus 2. So you get minus 2 is b into minus 1. So b is 2. Substituting in the next earlier expression, we get x by x plus 1 into x plus 2 is minus 1 by x plus 1 plus 2 by x plus 2. So integral x by x plus 1 into x plus 2 dx is integral minus 1 by x plus 1 dx plus integral 2 by x plus 2 dx. That is minus log mod x plus 1 plus 2 log mod x plus 2 plus c. Next question, evaluate integral x by x minus 1 the whole squared into x plus 2 dx. Here degree of the numerator is 1, degree of the denominator is 3, so we can apply partial fractions, and the denominator is factorized, so we write this as a by x minus 1 plus b by x minus 1 the whole squared plus c by x plus 2. So we repeat x minus 1 first with a single power and then with a double degree. Taking the LCM, you get x equal to a into x minus 1 into x plus 2 plus b into x plus 2 plus c into x minus 1 the whole square. To find a, put x equal to 1. So I get 1 equal to b into 3, or b is 1 by 3. Again put x equal to minus 2. So I get minus 2 equal to c into minus 3 squared, or c is 2 by 9. And now we expand the earlier expression, so we get x equal to, we expand this. So when you multiply, you get x equal to a into x squared plus x minus 2 plus 1 by 3 into x plus 2 minus 2 by 9 into x minus 1 the whole squared. These are the values of b and c. Or x equal to a into x squared plus x minus 2 plus 1 by 3 into x plus 2. You expand this, so you get minus 2 by 9 into x squared minus 2x plus 1. Now in the left hand side, the degree of x squared, coefficient of x squared is 0, and in the right hand side, coefficient of x squared is a minus 2 by 9. So we get a is 2 by 9. Substituting, we get x by x minus 1 the whole squared into x plus 2 as 2 by 9 into x minus 1 plus 1 by 3 into x minus 1 the whole squared plus 1 by 3 into x plus 2. Integrating, you get 2 by 9 integral 1 by x minus 1 dx plus 3 integral 1 by x minus 1 the whole square dx plus 3 integral 1 by x plus 2 dx. Now integrating, you get 2 by 9 log mod x minus 1 plus integral of x raised to minus 2 is x raised to minus 1 by minus 1. So it's plus 1 by 3 x minus 1 raised to minus 1 by minus 1 divided by the derivative of x minus 1, which is 1, plus 1 by 3 integral of this is log mod x plus 2 plus c. So that would be 2 by 9 log mod x minus 1 minus 1 by 3 into x minus 1 plus 1 by 3 log mod x plus 2 plus c. Next, integral x cubed by x minus 1 into x squared plus 1 dx. Here the degree of the numerator is 3 and degree of the denominator is 3, so we cannot directly apply partial fractions. When we open the denominator, we get it as x cubed by x cubed plus x minus x squared minus 1. Whenever the degree of the numerator is equal to the degree of the denominator, One method which we can do is divide the numerator by the denominator. So take the highest power here, which is x cubed, divided by the highest power here, which is x cubed. X cubed by x cubed is 1, and you multiply, so I get x cubed minus x squared plus x minus 1. Subtract, so you get x squared minus x plus 1. Now we use the fact that numerator by denominator is divisor plus remainder by denominator. So the numerator by denominator is, the divisor is 1, that is a quotient. So this is a quotient, plus remainder is x squared minus x plus 1 by x minus 1 into x squared plus 1. So x squared minus x plus 1, now I am taking this term, x squared minus x plus 1 by x minus 1 into x squared plus 1. I can write it as a by x minus 1 plus, since this cannot be factorized and it is of degree 2, we write it as bx plus c by x squared plus 1. So taking the LCM and cancelling out the denominators, you get x squared minus x plus 1 is a into x squared plus 1 plus bx plus c into x minus 1. Denominator of a, if you put it as 0, you get x equal to 1. So putting x equal to 1 here, I get 1 equal to a into 2, or a is half. So if you open this bracket, you get x squared minus x plus 1 is ax squared plus a plus bx squared plus cx minus bx minus c. So taking the degree of terms in x squared together, I get a plus b into x squared plus c minus b into x, the degree of x terms, and the constant terms is a minus c. The coefficient of x squared in the left hand side is 1, here it is a plus b, so a plus b is 1. Coefficient of x here is minus 1 in the left hand side, right hand side is c minus b, so I get c minus b is minus 1. Solving both simultaneously, I get b equal to half and c equal to minus half. So substituting here, I get I will be integral dx, that is integral dx plus this becomes integral 1 by 2 into x minus 1 dx plus bx plus c, 1 by 2x minus half by x squared plus 1 dx. That I repeat once more, we go back to this expression. Integral of this will be integral of 1, which is dx, plus integral of this, which is 1 by 2 into x minus 1 plus 1 by 2x plus half into x squared plus 1. So this is x plus half, integral of 1 by x minus 1 is log mod x minus 1 plus 1 by 2 integral x by x squared plus 1 dx minus half integral 1 by x squared plus 1 dx. That is, to integrate this, we make a substitution, put x squared plus 1 as t. So 2x dx is dt, or x dx is dt by 2. So your I becomes x plus half log mod x minus 1 plus half integral dt by 2t. Integral of 1 by x squared plus 1 is tan inverse x, so it is minus half tan inverse x. That is x plus half log mod x minus 1 plus 1 by 4 log mod t minus half tan inverse x plus c. And lastly, you substitute for t as x squared plus 1. So your I becomes x plus half log mod x minus 1 plus 1 by 4 log mod x squared plus 1 minus half tan inverse x plus c. Next question, evaluate integral secant squared x by 2 plus tan x into 3 plus tan x dx. Here we make a substitution, put tan x as t, so secant squared x dx is dt, so I becomes integral dt by 2 plus t into 3 plus t. Here degree of numerator is 1, degree of denominator is 2, so we apply method of partial fractions. So I write 1 by 2 plus t into 3 plus t as a by 2 plus t plus b by 3 plus t. Taking the LCM and cancelling out the denominators, we get 1 equal to a into 3 plus t plus b into 2 plus t. Put t as minus 2, so we get a as 1, and put t as minus 3, so we get 1 equal to b into minus 1, or b is minus 1. Substituting here, your I becomes 1 by integral 1 by 2 plus t minus integral 1 by 3 plus t dt. Integrating, you get log mod 2 plus t minus log mod 3 plus t plus c. Now log a minus log b is log a by b. Whenever we have two like terms in log, we take them together. So this becomes log mod 2 plus t by 3 plus t plus c. And lastly, you substitute for Ts tan x. So it becomes log mod 2 plus tan x by 3 plus tan x plus c. Thank you for watching. For more videos, subscribe to my channel and do send me your feedback through a comment.